Mole calculations. This is a topic that students often find quite difficult. It's a topic that I often get asked to review and reteach. The actual mathematics that's involved in it is not that difficult, but I think it's best shown in a series of examples. So this will probably be the first in a series of several videos where I go over some examples. In this video though, what I want to do is just give out the basic calculations that you need to use and when you need to use them. So first off, it's often referred to as the mole concept. So what is a mole? A mole is just a way of referring to a very large number of particles. So a mole is the number of particles 6 times 10 to the power of 23. It's a very big number. And this number is chosen because, that's Avogadro's constant, that's called. This is chosen because 1 mole of any substance, so if I have a mole of hydrogen atoms, or a mole of hydrogen molecules, or a mole of carbon atoms, or a mole of ammonia, 1 mole of any substance has a mass in grams that is equal to its relative molecular mass. The relative molecular mass is what you get when you add up the relative atomic masses. And the relative atomic mass is the larger number that is seen on the periodic table for each element. So for example, carbon has a relative atomic mass of 12. That means that 1 mole of carbon will weigh 12 grams. Hydrogen has a relative atomic mass of 1. So if we take CH4, methane, it has a relative molecular mass of 12 plus 4, so 16. That means that if I have 1 mole, 6 times 10 to the power of 23, methane molecules, I will have a mass, or that will have a mass of 16 grams. Okay. So that's what a mole is. The first calculation that you need to use is to be able to do that conversion. Convert between the number of moles and the mass from the relative molecular mass. And you've probably seen this triangle before. This is the triangle that you use, the mass-mole triangle. The mass always has to be in grams. Remember that. You've got to put it in grams first, so if you get given it in kilograms or something else, convert to grams first. The other two don't have units. The other two quantities don't have units. They're just numbers. So if we use this triangle here, then we can say that here are the 3 different calculations you need. Extrapolate it from that triangle, and depending on what you're trying to find out, you use a different calculation. So if you want to find the mass in grams, so the actual physical mass that you would weigh, then that is going to be the number of moles multiplied by the relative molecular mass. If you want to find the number of moles of something, then that is going to be the mass in grams divided by the relative molecular mass. If you want to find the relative molecular mass, you will use the mass in grams divided by the number of moles. Again, I'm just going to go through the 3 different equations that you need at the minute. We will look at some examples next time. Okay, because these are used for all different kinds of things. So usually things like reacting masses. So that is the first conversion, first calculation you need to be able to do between the mass in grams, the molar mass, which is the relative molecular mass, and the number of moles. The second thing that you need to be able to do is you need to be able to work out concentration from number of moles. Now for this one, you don't need the molar mass. So there's often questions where you have to use 2 steps. So you might have to use the first triangle and then the second triangle. First equation, then the second equation. Depends on what information you're given, and I think that's what students sometimes find difficult. But the triangle for concentration looks like this. N at the top stands for number of moles, C stands for concentration, V stands for volume. So this is where you take a substance and you dissolve it into a solvent. Now I want to stress this next part. This is really, really important. Volume here is volume of solvent. You have to know what it is the volume of that you are looking for. You can't use this for volumes of gas. You can't use this for other kinds of volumes. This is volume of solvent that things are dissolved into. The units are also very important. The number of moles is going to be in number of moles. If you don't have the number of moles, if you just have grams, you have to use the first equation to convert into number of moles. The concentration is in the unit moles per decimeter cubed. The volume is in the unit decimeter cubed, not centimeter cubed. Quite often you'll get given information in centimeters cubed, but you have to convert. In case you don't know, 1 decimeter cubed is the same thing as a liter, which is the same thing as 1,000 centimeter cubed. So 1 decimeter cubed is 1,000 centimeters cubed. So if you're given it in centimeters cubed and you want to convert to decimeter cubed, you have to divide your number by 1,000 first. Okay. So again, here's the 3 equations that you can extrapolate from that triangle. Got to know which one you want, which one you need. Again, next video we'll go over some examples. The third equation isn't really an equation so much as it is kind of a fact that you can use to work things out. And that is for gas volumes. 1 mole of any gas, and it's amazing, it's any gas. Doesn't matter what the gas is. Hydrogen gas, ammonia gas, water vapor, methane, neon. But 1 mole of any gas, if you've got exactly 1 mole of that gas, 6 times 10 to the power 23 particles, it will have a volume of 24 decimeters cubed. So it will take up a space of 24 decimeters cubed at room temperature and pressure. Room temperature and pressure is a specific number. It's 20 degrees Celsius and 1 atmosphere of pressure. But that means that you will need to see if it is at room temperature and pressure. So what does that mean? Well, it means if you know the number of moles of gas, you know how much volume it's going to be. And if you have the volume of a gas, then you know how many moles it's going to be, as long as it's at room temperature and pressure. This is where what I was saying before comes in, because one of the variables here is volume, but this is gas volume. Be careful that you're going to use the right equation, because if it's volume of a solvent, you use the previous one. This one is for gas volumes only. Now the unit is still decimeter cubed. So how do we use that? Well, if I want to know the volume of a gas, I take the number of moles that I've got and I multiply it by 24. If I want to know the number of moles of a gas that I've got, I take the volume and I divide it by 24. And that will give me the answer. What you can then do is you can go and convert using the other equations into mass or concentration, things like that. So that's the absolute basics for moles. What we'll look at in the next video is we'll look at some examples of how this can be used. Alright, thanks for watching.